Here a recurrence relation is given and we have to solve that recurrence relation. The given recurrence relation is t of 2 power k is equal to 3 into t of 2 power k minus 1 plus 5 and t of 0 is given as 1. If we expand the given recurrence relation, you would be getting the recurrence relation as t of 2 power k minus 4 into 3 power 4 plus 5 into 3 power 3 plus 5 into 3 square plus 5 into 3 plus 5 into 3 power 0. So if we solve this one, we would be getting solution as 3 power k plus 5 into 3 power k minus 1 by 2. So here the correct option is option D.
Number of final states required in a DFA to accept the following language, where language L is given as W such that W belongs to A comma B whole star all combinations of A's and B's, where W has odd number of A's and odd number of B's. So the total number of A's must be odd, total number of B's must be odd. He is asking not the number of states, he is asking the number of final states required. So the minimum strings in odd A's odd B's is AB and BA. These are the minimum string. Or you can have AB, AA, BB also. Total number of A's 3, total number of B's are also 3. Both are odd. It need not be 3. For example, you can have a AA, AB. So number of A's are odd, 3. Number of B's are odd, that is 1. So like that. So the DFA we can have like this. Q0. We can have 4 states for this. Q2 and Q3. Only one final state is sufficient, because minimum string is AB we can put and BA alternatively we can go in this direction. So we can give B here, we can give A here, just like you have the even number of A's, even number of B's in the similar sense. So you can get any, for example 3A's B you want, for example 1A, 2A, 3A, B, it will go for final. B, so it is reverse direction, this is not this direction. So B, 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 A also will come. So this is only one final state is sufficient for odd number of A's and odd number of B's. So option A is the correct option here.
Here the question is, if n is a power of 2, then minimum number of multiplications needed to compute a power n is, here 4 options are given and we have to find the correct option. Let us take n is equal to, for example, n is equal to 16. Then we have to compute a power 16. First we will compute a square by 1 multiplication. That is, a square is equal to a into a. A power 4 is equal to a square into a square. Then a power 8 is equal to a power 4 into a power 4. And again a power 16 is equal to a power 8 into a power 8. Here the minimum number of multiplications are 1, 2, 3, 4. So for calculating a power 16, we are getting minimum number of multiplications as 4. For a power 32, we will be getting 5 multiplications. Hence, here the correct option is option A. Here, an old man remembers first 8 digits of a 10-digit telephone number and he guesses the last 2 digits of the telephone number, and we have to find the probability of dialing the number correctly. Here available digits are 0, 1 up to 9. So here total 10 digits are there and the last 2 digits can be dialed in 10p2 ways. That is 10p2 is nothing but 90 ways. Out of 90 ways, only one way would be favorable case. So the required probability is 1 by 90, which is option B.
Match the following. So we are having two lists. The list 1 says this is PQRS, and list 2 1 2 3 4. Here in list 1 choke packet traffic shaping IEEE 802.5, and then we are having this time to live field in the packet header. The list 2 is containing congestion control, IP packet, ICMP and token ring. Choke packet is one of the method that we send a message in order to stop the packets. That is an ICMP protocol, that is internet control messaging protocol. When too many packets are arrived in a particular router, then this ICMP message must be forwarded to particular source that you have to stop. A direct way of telling the source to stop the or to slow down the packets transfer rate. So that's the reason choke packet can be assigned to 3, that is ICMP. Traffic shaping is one of the method of congestion control, that is Q is related to 1. IEEE 802.5, it is a token ring, and the time to live field we have included in the IP packet. So here P is related to 3, and then Q is related to this one traffic shaping. IEEE 802.5 R is related to this token ring 4 R4. Time to live field is a part of the IP packet. So here it is P3 and Q1 R4 and S2. So option C is the right option here. Option C is the right option. Organization is assigned with a class B IP network of 150.169.0.0. The subnet mask is 255.255.224.0. How many hosts are usable for the entire class B address subnetted this way? So here the class B address is given as 150.169.0.0 is a class B network address. So this network is assigned for one organization. So they can divide this total network into different subnetworks also. So the subnetwork also is given, that is 255 subnet mask 255.224.0. So actually in a binary format you can write like this. 255 means 11111111 11111111. 224 is 3 ones 0 0 0 0 0. This is again point, all zeros, 8 zeros. That means this is the network part, this is the host part in a class B. So there are 16 bits for the host part, but in a 224 I have already used 3 bits for the subnetwork. If 3 bits are used for subnetwork, remaining how many bits? 8 plus 5 bits are for the host part in a class B network. So total 13 bits. Using 13 bits we can have 2 power 13. So 2 power 13 is nothing but 8 into 1024. That is 8192. 8192 number of addresses will get, but we can't make use of all. In that these number of hosts are possible for every subnetwork. Like that, how many bits are reserved? 3 bits are reserved. So if 3 bits are reserved, 2 power 3 different subnetworks we can have. 8 subnetworks. In each subnetwork we can have entries. Number of entries will be 8192, but all we can't use. So we have to subtract 2 from this, because one is for subnetwork address, other is for broadcast within that subnetwork. So the total number of hosts we can make use is 8190 only after 2 are subtracted. So like this, these many hosts can be used for every subnetwork. How many subnetworks we can have using 3 bits? 2 power 3. From 0, 0, 0 to 1, 1, 1, these are the subnetwork IDs. So into 8. So we can have 65,520. 65,520. $65,520 is the answer. Option C is the correct option, because there are 8 subnetworks in this class B address. Okay, and each subnetwork can have a maximum 8190 usable hosts will be there. 8190 into 8 is 65,520. Okay, so option C is the correct option here.